To integrate quantum-safe cryptography with digital certificates in hybrid mode, it is not sufficient to only integrate quantum-safe cryptography as is, because the technical PKI ecosystem needs to change to accommodate hybrid cryptography. To make the challenge even harder, there are no plug-and-play solutions concerning the use of hybrid certificates, and they come with pros and cons. There are options for hybrid AND constructions and hybrid OR constructions. Additionally, the ecosystem around certificate verification needs to adapt to the introduction of an additional public key and signature. The process is different for the different types of certificates. In this lecture, I would like to share with you some challenges we encountered when dealing with integrating and managing hybrid certificates. During a Hapkido project, we worked on several proof of concepts related to hybrid quantum safe certificates. We will highlight the proof of concept where we signed and verified PDF documents using hybrid signatures. We chose PDF signatures due to the long-lived nature of the documents. Logically, the digital signatures must remain valid throughout the lifetime of the document, thus migration is quickly needed. To sign PDF documents, multiple standards exist. We focus on the PADES standard, which stands for PDF Advanced Electronic Signatures. PADES was designed and released by ETSI, the European Telecommunication Standards Institute. The standard allows a user to embed a digital certificate inside the PDF document, as you can see in the picture. The authentication of a PDF document is achieved by extracting the certificate and performing the validation of the signature and the certificate chain. A signature, which can be verified with the public key in the certificate, is made on the PDF and attached as well. The signature can either be visible with a stamp on the document or invisible. There exists official open source software called DSS that provides support for PDF signatures implementing the PADES standard and is designed to comply with the eIDAS regulations. The production of DSS was supported by the European Commission. This is how we approached our proof of concept. The PKI model was simply formed by a CA issuing the PDF certificate and a verifier, a PDF reader that could verify the signature and resolve the certificate chain. We wanted to make all elements in PDF signing hybrid. First, the certificate supported two cryptographic schemes, so two public keys for the signer, two signatures for the issuing CA, and the entire certificate chain. Secondly, the signatures contained in the PDF that can be verified with the subject's public keys were also used in hybrid mode. Only if both are verified successfully, it should show that the signatures is validated successfully. In other words, we enforced an hybrid AND scenario. We modified the implementation to support Catalyst certificates. Note that the implementation are for testing purposes and should not be used in production environments. The three main activities and their challenges are the following. First, we had to load the quantum-safe algorithms. We use the cryptographic library Bouncy Castle to perform cryptographic operations. However, the challenge is to add the respective OIDs to DSS. The OIDs were at the time of development not finalized, causing interoperability issues when using hybrid certificates from other libraries. Secondly, we had to locate in the source code of DSS all the places where the certificates were referenced and used. Since we were not the owners of the software, and because the codebase is quite large, this task was the one that took the most time. Third, after locating the certificates and their functionalities, we needed to replace the certificates with the Catalyst certificates provided by Bouncy Castle and change the logic of the operations. I will show you a small example. The function you see on the screen is taken from the original DSS implementation. Not every command is important here, but you can see in this function that the validity of the certificate is checked. If the check passes, then the public key is extracted. That public key is then used to verify the signatures on the PDF. Let's look at one example of how we had to adapt the code to support two signatures. This function is designed to provide the necessary information from the signing certificate. Let's now compare the original version and our adapted version. In the original code, the function setXML signing certificates ensures that the XML signature is properly configured. It retrieves the signing certificate and its chain and checks the certificate's validity using the default signature. In the updated version, we needed to add a step to ensure that the extra key is also provided and handled correctly. As you can see, the first part of the code remains unchanged and the functionalities to configure the signatures are intact. So we focused on this first second part of the code. In the original code, the validity checked is passed to the function, but if we add an extra key, the method remains oblivious of the fact that both signatures have been used to verify the validity and not only the default signature. Therefore, in the last step, we need to make sure that the software uses both public keys of the certificate to check the two signatures on the PDF file and produce an error if either of them fails. After introducing the Catalyst certificates in all parts of the code, we needed to make sure that our modifications would not interfere with the normal functionalities of DSS, so we had to extend the unit tests and make sure that all of them passed. Lastly, we needed to create an ad hoc PDF viewer. In fact, normal PDF viewers such as Adobe Acrobat do not support verification and visualizations of hybrid certificates. Therefore, we needed to include our fork of DSS in a PDF viewer we created so that the verification of two signatures could be performed and visualized. We were not the developers of the DSS software and we did not work full time on it, but our process took approximately 6 months to be completed. Our proof of concept is open source and available at github.com/tno/quantumsafedss.